This essay example, as well as thousands of others, is available in text format on our website for free and without registration. Simply Google Ivy Panda Free Essays.
What is soil? Soil is the sediment, the surface layer of land produced as a result of transformations in rock materials that occurred under the influence of both living and dead organisms, including plants, animals, and bacteria, solar heat, and atmospheric precipitation. Soil is a natural formation with a unique physical structure, chemical composition, and properties. Fertility, i.e., the ability to provide conditions for the growth and development of plants, is the most essential of its qualities. To be fertile, the soil should comprise a sufficient level of nutrients and water needed for the nourishment of vegetation, and macrofauna. This property distinguishes soil from other natural bodies, such as barren stone, which cannot contain two major factors required for sustaining life: water and mineral elements. Soil is the most important component of every terrestrial biocenosis, i.e., animal, plant, fungi, and microorganism aggregate united by their environment and inhabiting a particular land or water area. It is also a vital element of the Earth's biosphere as a whole. The soil cover allows the maintenance of multiple ecological links among all organisms living across different terrestrial layers, including the lithosphere, hydrosphere, and atmosphere. Soil plays a significant role in various human economic activities such as agriculture and household. For this reason, we should be aware of soil properties, as well as the factors contributing to its formation or deterioration, because the given information is essential to resolving multiple healthcare, ecological, and urban planning issues. Factors contributing to soil erosion. Soil erosion is the process of destruction of the surface land layers, which are characterized by the highest degree of fertility. Soil erosion can be either natural or accelerated, i.e., anthropogenic. When it occurs naturally, erosion proceeds at a very slow pace and usually does not result in a significant decrease in soil fertility. The accelerated type of erosion implies an irrational use of land and is associated with the activation and amplification of natural erosive processes. The irrational use of land includes such activities as inadequate soil treatment and irrigation, the excess input of fertilizers, grazing, deforestation, swamp drying, and so on. Two major natural factors that determine soil erosion are wind and water. Wind erosion, also known as aeolian processes, is defined by researchers as the emission, transport, and deposition of sand and dust by the wind. The strongest and the most enduring winds turn into dust storms, which can take off a large part of the nutrient-rich surface soil layer in a relatively short period of time. The important impacts of dust emission are the reduction of soil fertility and the consequent contribution to desertification and reduced agricultural productivity. Additionally, wind erosion changes the composition of the troposphere and, in this way, negatively affects the health of individuals who frequently inhale dust aerosols. Water erosion implies the destruction and flushing of the surface land layers under the influence of water flows. The ecological impact of water erosion is large. It leads to the formation of gullies and ravines, significantly reduces the nutrient content of soil and, as a result, causes soil infertility and development of hollow areas unsuitable for any agricultural activities. The land frequently exposed to this type of erosion loses from 7 to 13 tons per hectare of the most fertile soil per year. Preventive measures. Water erosion. Organizational works. Regular monitoring of land and development of maps and plans, evaluation of erosion processes, and design of strategies for prevention. Preliminary planning is regarded as the primary success factor in fighting erosion. Agromeliorative measures. Implementation of a crop rotation system aimed to conserve soil. It includes the implantation of perennial crops, the placement of cultivated plants on the slopes, and the development and installation of snow retention systems aimed to prevent the flushing of the ground by meltwater. Irrigation and drainage protection of soil. The implantation of forest strips on the slopes, the arrangement of canals for meltwater drainage, slope terracing, and the creation of dams and artificial reservoirs. These measures allow for direct water drainage on restricted routes and protect the main landmass. Wind erosion. Implantation of high-growing crops and forestation. Those plans may significantly reduce wind velocity and become an effective protective barrier to its negative impacts. Additionally, the increase in vegetation supports moisture accumulation. According to Koch et al., the presence of soil moisture can create substantial interparticle forces that inhibit the initiation of saltation, especially for sandy soils. Therefore, by increasing the capability to accumulate moisture, it is possible to mitigate the risk of dune development and reduce the level of dust emission and the rapid changes in weather and environment. Conclusion. The mentioned preventive agrotechnologic methods allow the achievement of positive results in the conservation of soil fertility. Overall, when selecting an approach, one should necessarily consider the geographical and anthropogenic factors that contribute to soil erosion in a particular area or region. Only when the causes of erosion are eliminated is it possible to attain a sustainable result, ensure the protection of the nutrient-rich layers of soil, and reduce the hazardous impacts on human health. This essay on soil erosion, its factors, and preventive measures was written and submitted by a student just like you. The Ivy Panda Samples database hosts thousands of works similar to this one on various subjects. Visit ivypanda.com to find what you are looking for, free of charge.